Hi, I'm Vaishnavi and I'm an ML engineer.
Hello, I'm Snehita Bodiga. I'm a full stack developer.
Hi everyone, I am Ashrita Bhimsetti. I am a front-end developer.
Hello everyone, I am Abhisanath Reddy Arepalli. I'm a backend developer.
Hello everyone, myself Shoaib Khan Patan. I'm a backend developer.
Hi guys, my name is Dhanush and I'm ML engineer.
Hello everyone, I am Neil Kamal Rana and I am the full stack developer.
Let's get started.
Right.
Mhm.
So we are Tech Titans. Our team name is Tech Titans. Our project name is Cybersentinel. Okay. Can you go to the next slide, Snehita?
Mhm.
So we have divided our agendas into six denominations. That is, first one is team and planning, user and product definition, technology and implementation, project documentation and management, tracking and evaluation, demonstrations and resources. We have denominated them into further denominations, but which is not, I don't think, is important right now. But going forward, we can explain you later. You'll know eventually how it goes on. Next slide. So, like we are our team members. I being ML engineer, Snehita being a full stack developer, Ashrita being a front end developer. Next slide, please. Abhi Sainath being a backend developer, Shoaib Khan Patan being a backend developer, Dhanush being a ML engineer, and Neil Kamal Rana being a full stack developer. So the improvements we have made this time were we made sure that we have an excellent Excel burn down chart, to be honest, and then we made sure again to correct the format for user stories, which we have been told again and again we couldn't do it in the last time also, and we made sure to include all the recaps of sprint 1 and 2 in a short summary wise. Coming to our project description, like I told you, our project name is Cybersentinel and team name being Tech Titans. So the project description is, I'll just give you an overview. That is, Cybersentinel is an AI-powered personal cybersecurity assistant designed to proactively, safeguard users against digital threats. By integrating advanced machine learning algorithms, it offers real-time monitoring, detection, threat detection, personalized security guidance to enhance users' online safety. For individuals and enterprises who need protection against cyber threats, and the Cyber Sentinel platform is a real-time AI-driven cybersecurity solution. Okay, it prevents from phishing attacks, fraudulent transactions, and identifies threats, and using advanced machine learning techniques, behavioral analysis, and cloud-based threat intelligence. So unlike traditional methods and traditional security measures that which struggle to figure out how to detect sophisticated advanced attacks in the modern day to day, our application employs AI powered risk and gives you real time solutions about this. So we have key components including that is user dashboard, which has security overview, recent alerts, system health check. The other part we have is threat detection and analysis. After that, we have personalized security guidance, and then we have automated security tasks. We even have something for user settings and customization, and we come with user benefits. So, benefits and outcomes, what we give are enhanced protection. That is, by leveraging AI, Cyber Sentinel offers proactive threat detection and offers you identifying and mitigating potential risk before they cause you harm. This is time efficient, cost efficient, it gives you a personalized support, and is user friendly interface. Okay, so just to sum up in a short way, we have Cyber Sentinel serves as a comprehensive cybersecurity companion combining AI and with capabilities of user centric features to provide robust protection and peace of mind. Just to be clear with it. Go to the next slide. So we have agreed on the team agreement. That is, we just made sure that our team members are included. We have, made sure we are having primary meetings. We have checkpoints. We have when we need mid sprint week meetings, and we make sure we are very professional about when we do it, and we do not make sure to gossip around sometimes in the calls. And rest everything, the communication part is made sure to everything goes in the smooth way. Next slide. So that's it from my side. Overhanding to my friend.
Hi guys, good evening. So from this slide, I'm gonna explain personas. So the first persona I'm going to explain is Alex Johnson. He works at a mid-sized tech company and is well versed in various technologies, spends considerable time online, both professionally and personally, aware of cybersecurity threats, but seeks advanced tools to enhance personal security. His goals are to protect personal and professional data from phishing and other cybersecurity threats, stay informed about the latest cybersecurity practices, utilize AI-driven solutions for proactive threat detection. So the challenges he faced is first thing balancing convenience with robust security measures, and second thing identifying trustworthy cybersecurity tools amidst numerous options. Though the second persona I'm going to explain is Maria Thompson. Manages a team remotely from marketing firm, juggles professional responsibilities with parenting two teenagers, uses multiple devices for work and personal tasks. Her goals are to ensure the security of sensitive work-related information, protect family members, especially children, from online threats, maintain a secure digital environment across all devices. The challenges she faced are limited time to manage and monitor cybersecurity measures, keeping up with evolving cyber threats, and ensuring family compliance with best practices. Sorry. The third person I'm going to explain is David Kim. He runs an online storefront in addition to the physical store, handles customer data, including payment information, has basic knowledge of cybersecurity but lacks specialized expertise. So the goals he wants to protect customer data to maintain trust and comply with regulations. Second thing, prevent financial losses due to cyber attacks. Third thing is implement cost-effective security solutions without extensive technology knowledge. So the challenges he faced are limited budget for cybersecurity investments and difficulty in accessing which security measures are necessary and effective. So next slide, Snehita. So I'm going to explain now is minimum viable product MVP. So here there are four MVPs. First one is phishing email detection. Uses NLP models trained on cybersecurity datasets to classify emails as safe or phishing. Helps prevent social engineering attacks by identifying malicious content in real time. Second one is fraudulent transaction detection. This applies anomaly detection techniques to flag suspicious financial transactions. This component supports real-time monitoring for enterprise-level financial systems. And the third one is URL classification. Analyzes lexical features of URLs to determine if a web link is malicious or safe or not. Provides an added layer of protection against phishing websites and driven by downloads. The fourth thing is user dashboard, a centralized interface that displays alerts, threat levels, and risk analysis in real time. It allows users to monitor cybersecurity threats and take quick prevention action. So, next slide, Sunita. The technologies which we use for this project are front end, back end, database, hosting. For front end, we use React.js for simple and interactive UI. For back end, Flask, lightweight Python-based API. For database, PostgreSQL to store detected threat data. For hosting, AWS for cloud deployment and scalability. Next slide. So the technologies which we use for this project, we mainly use AI and cybersecurity tools. For machine learning, scikit-learn, PyTorch for phishing and fraud detection. For security, OAuth 2.0 for authentication, OpenCV for URL analysis. For threat detection models, NLP, basic phishing email classification, anomaly detection for fraudulent transactions, and URL classification algorithms. So algorithms, my friend gonna continue, Afrika.
Thank you, Dhanush. Yeah, coming to our algorithms that we are using in our project are we have chosen three features for our in our project which we focused more. That is phishing email detection, fraudulent transaction detection, and URL classification. For phishing email detection, the algorithm that we chosen is BERT algorithm, that is bidirectional encoder representations from transformers. For fraudulent transaction detection, we have chosen autoencoder with isolation forest. And for URL classification, we have chosen CNN plus LSTM, which is convolutional neural network plus long short-term memory. Coming to phishing email detection, we have used this algorithm because it is a pre-trained deep learning model for text classification. So we don't want to train again our text or anything for classification and then it captures contextual meaning of words, improving phishing emails detection. And it also gives a fine-tuned on phishing emails datasets for high accuracy. Coming to fraudulent transaction detection, the algorithm is autoencoder with isolation forest. Autoencoder reduces dimensionality and extracts essential transaction features. And isolation forest detects anomalies based on a learned representations. And it is an unsupervised learning and it doesn't require any label data. We can detect the fraudulent transactions without any label data. And coming to URL classifications, as I said, like we are using CNN plus LSTM. CNN extracts spatial features from URL structure, and LSTM captures sequential patterns, improving detection of phishing URLs. And this is a hybrid deep learning model to give a performance like better performance, like provides a better performance. Let's know how these algorithms are trained to our model for our project. Coming to the first algorithm, that is BERT algorithm. Firstly, we cleaned up all emails and labeled them as a safe email or a phishing email. Then we used a special tool called BERT tokenizer to turn email text into numbers, and the model understands which one is a phishing email or which one is a safe email. Then we used a pre-trained BERT algorithm, which already knows like a clear, it already classifies it as it is a pre-trained data model. It already classifies the email and taught it to recognize which is a phishing email. Then we trained it for a few rounds using powerful tools like PyTorch and Hugging Face. And then finally we get an accurate value, accurate like whether the email is an phishing email or a safe email. And coming to fraudulent transaction detection, we trained the model by scaling the transaction data, whether it is consistent or not. Then we built a simple neural network called an autoencoder that learns the normal pattern of transactions. Once we trained the model, we used the middle part, which is called an encoder, and compressed the data. We passed to that model called isolation forest, which finds a strange and rare behavior, which detects an anomalies and based on the representations. If something looks odd, then it symbolizes it is a fraud transaction. And lastly, for URL classification, we turned each URL into a sequence of characters and padded them into the same length. We used a combination of CNN and LSTM to understand the sequences. Then we trained the model using labeled data and which says a safe email or a malicious URL. After training, we tested it with the new links to see if it could be a correct flag bad ones. That's it. And coming to the architecture diagram, you can see as Dhanush said, we are using React.js for our user interface. Then we are using a Flask API, which we take requests from the user and returns the results to the user. Then when we see a URL or any fraudulent transaction or any like phishing emails, then it will be stored in security external security APIs, and we store that data into a PostgreSQL. The AI models will detect whether it is a fraudulent one or not. Then all this data will be reverted to Flask API and gives back to the user. Next slide, please. Yeah. Coming to the context diagram, as I already said, when user gives the input like email, URL or transaction, our Cybersentinel system will detect whether it is a fish, checks a phishing email or fraud email. If and using the algorithm that I already explained, it reflects the result to the Cybersentinel system and notifies the user. And these results will be stored in a PostgreSQL which are using in our backend. And each and everything will be fetched from the external APIs, and everything will be like noted in our APIs with a security. That's it. Next slide, please. Coming to the ER diagram, in ER diagram user we need a user ID, name, email, and password for logging into our system. And then for transactions, we need transaction ID, user ID, amount, and timestamp and status to detect whether the transaction is for fraud or a safe transaction. And for URL email detection, like we need email ID, user ID, subject, sender name, body, and classification. And for URL, we need URL ID, user ID, URL, and risk level. It reflects to the user. Back to that. Next slide, please. Okay, thank you. Snehita will continue from here.
Yeah. Coming to the sequence diagram, this diagram walks through what happens when someone uses our system. The user enters something like an email, a link, or a transaction. That data goes from front end to back end, and this analyzes the data, figures out if there is a risk, and saves the result. Then the backend sends that analysis back to the user. It's a smooth back and forth that makes whole process fast and efficient. So next slide. So here is the flow diagram. It reacts depending on what's happening. It starts off idle, just waiting. Once someone submits something to check, the system springs into action, analyzing, scanning, and deciding how risky it is. So, based on that, it can classify the input as safe, suspicious, or dangerous. So, if it's a threat, the system alerts the user and logs the event so we can learn from it in the future. Coming to the class diagram, this diagram breaks down how we have built the system using object-oriented design, basically organizing it into reusable building blocks. We have different classes for users, emails, transactions, URLs, each with their own roles and properties. At the center which does the heavy lifting when it comes to the threat detection. So this kind of structure make our system more flexible, scalable, and easier to maintain as we grow. Coming to the sprint 2 recap. So the team successfully completed 7 user and technical stories, delivering a total of 63 story points. And the key achievements included implementing phishing detection via email upload, transaction fraud detection, malicious URL checks, and sender verification. So overall, the sprint demonstrated strong progress in code detection features despite minor backlog carryovers to Sprint 3. Coming to the product backlog user stories. So in Sprint 1, we focused on giving monitoring users the ability to track phishing history. And coming to the user story 2, email recipients needed a way to filter emails based on how risky they are. So we built a feature that classifies emails as safe, suspicious, or phishing. And coming to the user story 3, here we added a dashboard that shows threat stats, like how many phishing attempts were detected, helping them evaluate the effectiveness. So coming to the user story 4, admins needed a better control over who can access what and what. So we implemented user role and permission management, and now responsibilities and access are clearly defined. Coming to the user story 5. For Sprint 2, we planned a feature where reviewers can upload suspicious emails. The system analyzes them and gives a phishing risk rating. So, so these user stories are advanced features in Sprint 2 and Sprint 3. In user story 6, our finance team wanted to detect fraud using uploaded data. So this story, which we prioritize in Sprint 2, so this uses machine learning models to flag unusual or suspicious transactions. And user story 7, it's a URL safety check. And user story 8, we also worked on verifying email senders, helping users quickly see if an email really came from it who claims to. So, like this build users confidence and stops phishing. Coming to the user story 9. So it's a system user, and we plan to add real-time alerts for this. In the user story 10, we finally giving users a way to report false positives, emails flagged incorrectly. So this feedback help us to retrain our models and improve accuracy over time. Neil will continue with this.
Yeah, thank you. Now coming to the technical stories, that is nothing but the technical part of how the user stories are being used and are being run onto the system. Coming to the first technical story, that is the development of the dashboard. So the important thing for this application was to have a very good dashboard where user can probably see and detect whatever the emails and whatever the fraudulent things are happening. So the first technical story was all about the setting up of the dashboard. Coming to the second technical story, this was related to the user role. Like we have decided on to have two user roles. The one who will be the admin who will be monitoring the system, and the other will be the users who will be using the application. Coming to the third technical story, the third technical story was implementing open authorization authentication. We were implementing open authorization and authentication for the authentication and for the user privacy, so that user can have their own privacy depending upon what the user role is, whether it is of an admin or whether it is of an user. So the next technical story was of like the setting up of the AWS. So we have set up everything into the AWS, from the database to everything, and probably our backend server was also in AWS. So these were the four major technical stories that we have covered into the sprint 1 that we have planned and intended to cover into the sprint 1. Now coming to the sprint 2, the technical story number 5. And from here, all the stories are related to training the models. And yeah, so let's see the technical story number 5. The technical story number 5 was integrating a bot model. So we have integrated a bot model which can detect phishing. And this model during the sprint have achieved a very good accuracy, like which have achieves accuracy of around 90%. Coming on to the technical story number 6. The sixth technical story was implementing an auto encoder, which is gonna help in finding the fraudulent transaction details. So the auto encoder was using the isolation forest. That is again a machine learning thing. Coming on to the technical story number 7. Our technical story number 7 was detecting false URL. So like we have implemented convolutional neural network and long short-term memory models, which will be keeping in the memory and saving all the URL that has been marked flagged. Coming on to the technical story number 8, which we also covered in sprint 2, was implementing a email sender verification model, so that we can check whether the sender who is sending the email is a genuine user or not. And yeah, these are the technical stories that we have covered or intended to cover in sprint 2. And the last two user stories, technical stories that we have covered in the sprint 3 are technical story number 9, which is related to developing a notification system. So yeah, I will like to go a little bit detail because this is the first time we are explaining these technical stories. So we have developed a notification system which definitely works on like whenever we are receiving an email from anywhere to the user who have registered on the app, that email will be first be going through our machine learning models, and probably that machine learning model will implement auto encoder and obviously the isolation forest, and will check whether that email is a genuine email or not. And then if it is a genuine email, that is, it will be marked safe and no notification will be sent to the user. And if there is something phishing, then probably the user will be get notified in this. And the next technical story that we have covered in this sprint is the technical story number 10, which we have developed to manually false report positive the reports which the system has marked flagged or is genuine. There are cases where we find that the genuine emails were also being marked as phishing or maybe marked as fraud. So we have given a chance to the user where the user can mark them as false positive, and depending upon that feedback, the AI model can learn the thing and can work onto that. So these two are the major technical stories that we have covered into the sprint 3. Okay, now I'll go to very quick the summary, like sprint, as this is the last presentation, so I'm covering everything. Coming on to the sprint 1 summary, we were able to complete 37 story points out of the 15. The two story points that we were not able to cover were the open authorization and the user role thing, which we carry forward in the next sprint. All in all, the sprint 1 was good, depending that the team was new and we were able to set up everything. Coming on to the burn down chart. For the sprint 1, we can see we have a very nominal sprint 1 burned out chart that like we started working from the very first day. The team was new, everybody was wanting to work. So probably we were able to match with the ideal burn down. But as the project progress, you can see that between after first 2 days, there is a horizontal line just because we encountered some problems. There were mostly new tools that we have to learn, and probably we decided to dedicate that time to learning new tools rather than working on the project. So probably we spent a couple of days learning those things, and then we were back again onto the project. And from there, we were working on and off, and probably you can see regular horizontal lines where we have were not been able to work. So that is the time we have dedicated to learning new things rather than working on the project. And yeah, once we were able to learn things, and then we were able to work onto the project. So the sprint burn down chart goes as follows. And yeah, at the end, we were not able to complete the two story points, what, 13 points. That's the difference we can see on March 12 from the ideal burn down. And next is the sprint 2. Sprint 2 was the best part of the project where we were able to complete like 63 story points out of the 76. And again, those 13 points that we have not covered in the sprint 1 was again not been covered into the sprint 2. Those two, we thought it to be a small thing, but it was not a small thing. Obviously, the user role and the open authorization. So yeah, it was still a pain for us in the sprint 2, and we take it to the sprint 3. Coming on to the sprint 2 burn down chart, you can see the horizontal line in the beginning, and that is where we were again. We have just completed the sprint 1, and probably no one was wanting to work knowing that deadlines are not so near. So probably we have given it like first 3 days that no one works, or maybe they were working on their own things. So after that, after a little break, we were again back to the project. And as you can see in the burn down chart, we were working on and off, on and off. It was going good, sometimes it was not. But yeah, at the end, there was a continue working on the project, and we were still able to complete everything. But again, those two story points that have not completed in the sprint 1 was again left at the last of the sprint 2. So yeah, coming on to the sprint 3. So sprint 3, quote to quote, in sprint 3, we have done 6 of the user stories and technical stories. 4 were fresh and 2 was carryover. The last two you can see on the screen, those 2 was carryover from the sprint first itself. And the fourth fresh that we were done was to develop the notification system and to develop the false positive reports where the user can mark the flagged email as positive emails, as genuine emails. Coming on to the test cases, from here my friend will take over.
Yeah. Hello everyone. So here are the test cases for Sprint 3. So this slide outlines test cases for the first five stories. So we tested phishing detection alerts, false positive reporting, and notification promptness. All test cases passed, confirming that notifications triggered as expected. And then reports were properly flagged here. The feedback mechanism logged responses successfully. So here that test cases 1, 2, 3. So we have five things here. Additionally, the role assignment test validated that different user access levels were working as designed. The next slide, please. Here are the test cases 6 and 7. Here we validated the open authentication system. We tested both valid and invalid login scenarios under test technical storage 3. In both cases, the system responded appropriately, allowing secure access when credentials were correct and blocking access with an error message when they were not. Mm, this completes testing for the two carried over stories. Next slide, please. This here in Sprint 3, the stories completed are like all 6 stories committed to Sprint 3 were completed. This includes alerting, false positive feedback, real-time notification, role management, and secure open authentication login. The total story points completed this sprint around 80. This sprint amounted to 35, marking full delivery against the commitment. Next, the team velocity. Coming to team velocity, the total story points completed is 35. So while this is lower than the previous sprint, so the stories were more integration and feedback focused, which required coordination across components. So the team maintained consistent throughout despite this. So next is the team's historical velocity. Here in sprint one velocity was 37 story points. In sprint 2, it's 63 points. In sprint 3, it was 35 story points. So coming to team's historical velocity, that on average, it was like 40 story points. Coming to bound, this is the main thing here. This is the burn down chart for sprint 3. This the sprint 3 burn down chart shows as a steady decline in story points, aligning well with the ideal trajectory. So most of the work was front loaded with a couple of small dips reflecting mid sprint testing and debugging. So we finished with all the committed points completed, and then which is reflected in the clean drop towards the end. So as you can see, the up and down, and then at last we fulfill the burn down chart, like we completed that thing. And next slide, please. So completed to committed ratio in sprint 1, like it was 74%. In sprint 2, it was 84.8%. And then in the last sprint, we are like 100%. We hit up the target. Next slide, please. So the retrospective, here we can see like what went well and then what can be improved, and then action items. So as a team, we decided like what went well, like strong teamwork, on time delivery, good planning, clear goals. So all these things went well in this sprint 3. When it comes to what can be improved, so we can improve like that time management, and then bug delays in the sprint 3, and then the team coordination was missing some, so we can improve that. And then in coming to action items, it does like start early, track progress, and then updated documentation is that's thing. Next thing. So these are the application's key screenshots. So Abhi can continue from this.
Yeah. Okay, so thank you, Shoaib, for giving me. These are the application screenshot. This is our dashboard, like which has we can, as you can see, we can filter from the risk levels like suspicious, safe, and malicious. And this is our dashboard. So next screen, next slide, please. And these are our analysis tools, which can be used only by the admin and not the viewer. And admin and analyst can use these. So like we have email analysis, transaction fraud, and URL checker. Like we can analyze all of these by uploading the documents and everything. Next slide. So this is our URL safety checker. Like as you can see, you can enter the URL and you can tap on check so that it analyzes and it gives us a report. Like it shows us like how much uh, how potentially dangerous or how is it. Like if it's safe, it shows us and safe. And you can check another URL and you can close the tab. Next slide. This is our login page. Like here you can log in if you are a user already, or you can just register as a new user. You can register as a user, as a admin or analyst, or you can uh, register as a user, as a viewer. Yep. Next slide. This is our register here page. Like you can give the email and password for this. Next slide. Okay, so yeah, this is our risk. Like this screenshot shows like how we can flag any 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 response which will be given by the from our Cybersentinel. You can flag them, and if it shows as if it currently classifies as suspicious, you can give them new classifications as you can select phishing, suspicious. Like if you think that the our model has given a wrong wrong classification, you can just flag it up and you can just give a feedback so that it can take the feedback and it corrects itself and it can change the classification. Next slide. So and this is what we worked in this sprint. Like it should show us real time alerts. Like it has a notification. Like if we change if we flag it and if we give some feedback and if you want to change the classification, what how we feel, it it takes our feedback and it changes the classification and it gives us a real time notification for us. Next slide. So these are our API screenshots for the fraudulent transaction and URL classification APIs. So here we see two additional API endpoints. The first is the fraudulent transaction detection. It uses an auto encoder and with isolation forest to identify anomalies that may indicate fraud. And the second endpoint here relates on URL classification. It leverages a hybrid CNN LSTM model, as Ashita explained, to determine if a submitted URL is safe or malicious. Both endpoints are integrated into the front end to provide immediate responses to users during their security checks. And this is also the screenshot for our API. Yeah. This is our GitHub wiki page link. Mm. So the application demo will be given by me, but first the code will be explained by Sneeta. After that, I can give the application demo.
Okay. So coming to the core, uh, let's do this and SRC. So let's get started with layout first. So this code represents the root layout component that sets up the font configurations, applies metadata for SEO, and this wraps up the application in the provider's component for context sharing. So this also applies global styles from global.css file. And coming to the page, so this is an entry point for the authenticated dashboard that renders the phishing dashboard component within auth card. So this redirects unauthenticated users to log in. And coming to the login page, so this is a client side login page with form handling for email password entry, error state management, integration with the auth context, database authentication via API endpoints, and navigation to dashboard upon successful login. This is it. And coming to the register page. So this is the user register page that collects all email, password, and role selection, and it performs client-side validation. This registers users with different permission levels in the database, and it redirects to login after successful registration. And in this API endpoints, let's go to analyze. So this is a core analysis endpoint that accepts email data, constructs a detailed prompt for ML API, makes HTTP requests to your custom ML API endpoint, and processes the JSON response with phishing indicators. It also handles errors and edge cases. It returns structured analysis results and stores analysis results in the database. Now, in the in this is a database connected API route that handles CRUD operations for email data, supports filtering and pagination, implements access control based on user roles. Now let's go to components. So this is a protection wrapper that checks authentication state with server-side validation. It displays loading indicator while checking and redirects to login if no authenticated user. And it renders children only for authenticated users. And let's let's go to email dashboard. So in the email dashboard, so this is a main dashboard container that fetches email data from the database via API endpoints, and it manages global state for emails and filters. It renders dashboard headers, stats, and email table. It also handles tab navigation between dashboards and tools. So in the dashboard header, this is an application header with branding and navigation, user profile drop down, notification system connected to the database. And coming to the statistics visualizations showing, this is a real-time email risk summary from the database, and it also have malicious URL metrics and fraud attempt statistics. Mm. So this is an interactive email list that displays emails with server-side pagination, provides sorting and filtering through API calls, shows context menus for actions, and opens detailed view on click. Coming to the email detailed model, this is a comprehensive email analysis that fetches detailed email data from the database and shows full email content. It highlights detected security issues and provides action buttons based on user permissions. So, so this is an email submission form that collects email details and sends to analysis API and displays real-time analysis results. It also handles API errors with fallback to mock analysis. Coming to the flag correction. So this is a risk classification feedback that allows suggesting different risk levels and stores feedback in the database for the improving system. So in this UI controls for filtering emails by risk level, status, search term, and sends filter parameters to API endpoints. Notification drop down. This fetches the notifications from the database and shows the alerts for security events and allows navigation related to emails, supporting clearing all the notification and all. And in the security tools, these are the additional security tools container, uh, which contains like tab navigation between tools and integration with email analysis. Into the transaction. This is a financial transaction security that uh, analyzes transaction data for fraud, supports CSV and JSON file, sends the data to backend for analysis, and provides recommendations based on the risk. So this is a URL safety analysis that checks malicious or suspicious URLs. Navigation user. This is a user profile navigation with profile information display from the database and role indicated, and logout functionality with session management. Mm. And coming to the libraries. This is an authentication state manager that provides login, register, logout functions with database integration and manages user sessions with JWT tokens. It also makes auth state available throughout the app and handles loading the states. Coming to this. So this is a configuration and styling constants based on the risk level styling and icons and email status configurations, role permission mapping, etc. Notification system fetches the notification from the database as I already discussed. So let's go to other one. This is a TypeScript type definitions for user roles and permissions, email and attachment structures, risk levels and statuses, dashboard statistics. And let's go to the other one. So this is an email filtering hook that manages filter state and constructs API queries with filter parameters and handles search queries. It updates filtered list when data changes. Now, so this is the code explanation and Abhi will explain the remaining part.
Okay, thank you, Snehita. So here is our Cybersentinel login page. Like here you can see the email, password, and register here. So let's start with registering as a new user. Like so, let's give a name like Mark 3. So we can give the password and see we have three roles over here. Like we have admin, analyst, and viewer. Like I'll just explain what what the three roles will be having. Like as an admin will be having full access to all the features, and admin can block and delete emails, and he can manage users and settings too. And he has access to all the security tools. And for the database, he'll be having all the enforced access controls. And for the analyst, he can analyze and block emails but cannot delete any emails. And he has access to all the analysis tools, can suggest corrections, and he has limited database write permissions. And for the viewer has only read-only access to dashboards, cannot take actions on any emails, can suggest the corrections to classifications, and he has very limited access to the tools, like he cannot use any security analysis tools, and he'll be having read-only permissions for the database. So let's first register as an admin. So, let's log in. So here you can see this. Okay. So Mark has joined as an admin. So this is our dashboard. Like we have our dashboard shows like how many did we check till now. Like we just checked six of them, and it has two safe, two suspicious, and two phishing. And for as since we are logged in as admin, we can use the security tools. Here we can see all those, and we here, as explained in the application screenshots, we can just segregate them by filtering with suspicious, safe, phishing, and everything. So let's go to the security tools. Like so, we have three of them: email analysis, transaction fraud, and URL checker. For the email analysis, let's try to add an example email to check how it's working. Okay, so let's give it for analysis. So the bird model analyzes everything and it gives us a feedback by classifying it. So this is our result. Like this is showing us as phishing email. And we have added, like we can add this to our dashboard, add this email. So let's check that if it's added to our dashboard. So yes, as you can see, this is added as phishing and it will be flagged itself. Okay, let's try safe. Analysis. This is showing us as suspicious, not like phishing one. So we can add this one also to the dashboard. Mhm. So as you can also see, like it's giving us real time notifications, like with what we searched, what we gave for analysis, and how what result it's been giving. Um, okay, then let's try transaction fraud. It's so so it checked our transactions and it also categorized everything, and it's showing us like two transactions are being flagged. Okay, we can upload files to like to we can upload a statement or anything to just check. Let's try this URL checker. Google. See, like we just searched Google and it's showing as safe. Let's try. I'm just giving randomly. So it's it's giving us correct result. Like it's classifying everything correctly. Okay. So these are security analysis tools which can be used only by the user and the admin. And what we can do is like we can also the admin has access, like he can view all the details, he can block the emails, and he can delete that too. Like I just deleted one. So this is for the admin. Let's try to register as a viewer. So, okay, let's register as a viewer. So like it's showing us as user. So we'll be not having access to any security tools to analyze anything. We can just have a look at the dashboard and all the emails. And as you can see in the actions, we can view the details and we can just suggest a correction. That's it. We cannot delete or block anything like because we are logged in as a user. So let's try suggesting the email. Like let's try suggesting anything. It's already flagged as phishing. So the current classification is phishing. So you can give it as suspicious, safe. Let's give this as suspicious, and we can give any feedback which we want to why we think this email should be reclassified. Let's submit the correction. So we can submit the correction, and as you can see, we just got a notification that the security level for the unusual sign-in is updated as suspicious on the feedback which was given by the user. So we'll get a notification of that. And as you can see, it's changed to the risk level has been changed to suspicious. Okay. So and let's try to log in again as an admin so that like what changes which have been given by the viewer which can be seen by them. So let's try. Okay. So as you can see, this was being flagged as suspicious change by the viewer, and it's reflecting in the admin's account too. Like as you can see, it's showing as suspicious. Okay, that's it for the application demo. Thank you.